Hello! I want to say hi. I'm going to share something really awesome that I learned yesterday in my class that I've been taking. So, a little bit about this class. It is called Teaching Mathematical Thinking. And it is a requirement for the state of Idaho for teachers to take before they recertify. So, we talked a lot in our class, are talking a lot in our class about modeling mathematics. One of the things that we talked about was the area model, which was a model I already knew about. And I'm going to flip you guys around and do math on a whiteboard. But while we get people going, the area model is first introduced in elementary school to teach multi-digit multiplication. So taking that area model and applying it into algebra and into factoring. You guys, I am not kidding you. This is life-changing area models from elementary school, multi-digit multiplication, into algebra with binomial and trinomial multiplication, into factoring. So I'm going to flip you guys around. All right, here we go. Okay, so the area model is first introduced in elementary school when we do things like 26 times 41. And so the kids break up 26 is 20 and 6, and 41 is 40 and 1. And then I go through and I multiply my squares. So 20 times 40 is 800. 6 times 40 is 240. 20 times 1 is 20. 6 times 1 is 6. And then I can go through and add up all my pieces. So 800 plus 240 plus 20 plus 6. So we get, oh gosh, that's 1,000. That's 60 and 6. 1,066. I almost put a dollar sign in front of that. Okay, so this is introduced in elementary school. So this square is an area model. Now, they do this a lot. They get really comfortable with it. Pro tip, I drew this part in Sharpie because the Sharpie will come off when you scribble over it with an Expo marker. Also, side note, these Office Depot Expo markers are surprisingly decent quality. Okay, so we start using this in algebra when we start multiplying binomials. So remember a binomial, you probably don't know the name, but you would recognize this. 3x plus 2 times x minus 5. Okay? This was introduced to most of us as FOIL. And so we would do first, outside, inside, last. It was a weird acronym. You had to memorize it. No one really knew what it meant. And things get really tricky when this has 3 pieces to it. So, I have a YouTube video about this part, talking about why this is my favorite argument for why Common Core is not a bad thing. This is why Common Core is doing good things. So same thing, I'm going to take my binomials, put each piece in each part of the square, okay? And then I go through and I multiply my boxes. So 3x times x is 3x squared. 2x times 2 is 2x. 3x times negative 5 is negative 15x. And 2 times negative 5 is negative 10. Okay? And then I can write this out. So we are using the area model to multiply binomials. So we first use the area model to do double-digit multiplication. Now I'm multiplying binomials. I combine my like terms. My final answer is 3x squared minus 13x minus 10. Okay? So this is so intuitive for the kids. They've seen this model before, and so to take these pieces and put them in here and fill in the box is so easy for them. Eventually they do see the pattern and like to distribute, and we show them distributing so they don't have to draw the model every time, but it's an amazing way to introduce this. Alana, I love teaching it this way too, especially with trinomials. Hi, Dad. Especially with trinomials, this works so well when FOIL just falls apart when you're doing trinomials. So this is where it gets so good. Okay, so we did this, and I was like, yeah, I've seen that before. But if I can use this to multiply, can I use this to go back and factor? Hi, Dad. So, are you ready? Are you ready? Are we ready? I can't show you my face, so I'm showing you my hands. Are you ready for this? Okay, I'm telling you guys, Rachel's seen it before. It's amazing, huh? So, x squared plus 5x plus 6. So I'm going backwards, right? So I know that the x squared is going to go in this box, and the 6 is going to go in this box, okay? And this is where it gets a little bit different. So the 5x has to come from these two together, 5x, okay? So the only way I can multiply to get x squared is with x and x. That's my only option. Then I'm going to go through and figure out how do I multiply to get to 6. Well, one option is to do 1 and 6. So if I have 1, that is 1x. If I have 6, that is 6x. 6x plus 1x, because they're both positive, does not give me 5x, okay? So that one doesn't work. Also, with this method, I highly recommend we be using whiteboards because of all of the erasing and guessing and checking we're doing. The other factor pair for 6, so we're factoring with an area model. The other factor pair of 6 is 3 and 2. So this would give me 3x here, 2x here, 3x plus 2x is 5x. So the inside is filled out correctly, which means that my answer, my factors, are what's on the outside, okay? So my factor pair is x plus 3 times x plus 2. Boom! Boom, 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 boom. Let me do some jazz hands. Woo! Look at that. Oh my gosh, it's amazing. Okay? Seriously, I'm like geeking out about this for 2 days straight. So, I don't have to do any weird diamond methods. I've heard diamond method. I've heard the AC method. I've heard Batman, the box method, which might be something similar to this. There's all these different things, straight guess and check. This is basically straight guessing and checking, but it gives them a way to organize their guess and check in a way that's familiar to them. So, it gets even cooler, you guys. Are you ready for this? Are you ready? Boom, 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 boom. Okay. Oh, here we go. What if it's a harder problem? What if it's harder? What if it is something like 3x squared plus 7x plus 2? Okay. Again, these are really hard. Typically, historically, they are hard because that is not a 1. But with this method, it's cake. So again, I fill in my area model with the original or the answer, right? The result of multiplying, which is 3x squared here, 2 here. Okay? Also, if we've been teaching them to multiply binomials with this method, it's so easy for them to put this in the box because they've been using the box to multiply. So, Again, these two are going to add up to 7x. And we're going to fill in. So for 3x squared, my only options are 3x and 1x, okay, to get to 3x squared. The 1x, you don't have to have the 1, blah, 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 blah. And again, these have to add up to 7, okay? 2 only has one factor pair option of 2 and 1, and I'm going to do this wrong on purpose. So I'm going to put 2 here and 1 here, okay? This is going to give me the wrong answer, but that's okay, because I want to show you this. So 2 times 1x is 2x. 3x times 1 is 3x. Okay, 3x plus 2x is 5, which is not the 7 that I need here. So that is wrong. But 2 and 1 was my only option for factoring 2. Okay, but, there's a but. 3 and 1 are different. So with having 2 and 1 here, it makes a difference if I switch places and put 2 here and 1 here. So I'm going to do that. I'm going to erase all my pieces. Again, this is so much easier if you have whiteboards for your kids to use. Oh, I forgot which one was where. Okay, 2 is going to go here, 1's going to go here. So we get 1 times 1x is 1x, 3x times 2 is 6x, so 6x times 1x is the 7x we need. So then my answer to factoring is this, and we have 3x plus 1 times 1x plus 2. Bing, bam, boom, done. What? I'm telling you guys, this is life changing, okay? It's amazing. So, super easy transition from elementary school using this to multiply multi-digit numbers into multiplying binomials. So starting here and multiplying to get this. And now we're taking this and factoring to get this, okay? Algebra tiles also is a great way to go, because then you can visually see your squares that you're creating. Okay, there's one more I want to show you. We're going to get even harder, okay? 4x squared minus 11x minus 20. I have negatives. I have big numbers. I have a not equal to 1. Oh my gosh, I'm going to panic. I'm going to die. No, you're not. Watch and learn. So, again, we fill in our pieces. 4x squared and negative 20. Okay? Then 4x squared, there's lots of options for, or not lots, there's 2 options for multiplying to get to 4, okay? Most kids think about multiplying to 4, they think of 2 and 2. So 2x and 2x. Then I'm going to go through my options for negative 20, okay? There is 1 and negative 20. The other nice thing about this is we can deal with negatives really easily. So 1 times 2x is 2x. 2x times negative 20 is negative 40x. Oh, I forgot to put this part in. This guy needs to be negative 11x. Okay? Clearly not negative 11x. The other thing that's really handy with this method is I can super easily switch the negatives places, make that one negative, that one positive, doesn't change my answer. The kids will pick up on really quickly that the negative, like switching just the negative places, only makes this change signs. It doesn't get me any closer to that answer. So that didn't work. Okay. So we're going to try negative 2 and 10. Again, negatives kind of work themselves out. So we get negative 4x and 20x. That's going to give me 16. If I switch the negative, I get negative 16. Still wrong. So then we're going to do 4 and 5. Negative 4, positive 5, gives me negative 8x and 10x, which is 2x. So it's not going to work. At this point, I have tried every possible combination of negative 20. None of them have worked. So what that tells me is this is wrong. So I'm going to go back to this. I'm going to erase all of this. Okay. So we're using our area model to factor. Go all the way back to the beginning. This is like a crazy hard problem. If I gave this to my students, they would like panic. Okay. So we tried 2x and 2x. My other option is 1x and 4x. The other thing I love about this is it doesn't matter where I put the 1 and the 4. Okay? It all works itself out. So we get to try our factors of negative 20 again. So 1 and 20 gives me 20x and negative 4x. Again, that's 16. Not going to work. But, oh, gross. I didn't wait for that to dry. Here's the other thing. Because this is a 4 here and a 1 here, I also need to try switching places. Okay, so I'm going to try putting 20 here and negative 1 here. Because that's going to give me different answers because these two are different options. So 4x times 20 is 80x. 1 times negative 1 is negative 1x. That's way too big. So that's way wrong. That's a no-go. Okay. Next option for factors of negative 20 are 2 and negative 10. Again, the negatives don't really matter. They figure themselves out. So we have 2 times 4 is 8x. 1x times negative 10 is negative 10x. Those add up to negative 2. Again, if I switch the negative, make that one positive, make that one negative, it's a positive 2. Still not what I'm going for. Okay? So we're going to erase those. Again, I keep saying again, I'm sorry. I had 10 here and 2 here. I also need to try switching places because the 1 and 4 are different. So I'm going to put 10 here, negative 2 here, negative 2x, 40x. Nope. Can you tell that I made sure it was the very last option? You're going to sit here as we struggle through this whole thing. Okay. So last option is 4 and 5. So if we do 5, 4, 5 times 4 is 20. 1 times negative 4 is negative 4. I need my x's. Doesn't work. Okay, that adds up to 16. I need to try switching them places. So I'm going to make this negative 4 and this 5. And we get 5x here, negative 16x here. Finally! Oh my gosh. This was a lot. I get my answer. Negative 16x plus 5x gives me negative 11x. So my answer to this problem in factoring gives me 1x minus 4 times 4x plus 5. And I'm really excited about using this to teach factoring to my students because this model, this area model, is so intuitive to them. I'm going to take you guys off and talk to your faces. There we go. It's so intuitive. Like, it just clicks. This is a model that they know, they've used. It's super easy. Like, this last year, I did not teach multiplying binomials using this model. I didn't teach it that way, but I had students use it on their own because they're so comfortable with it and they like it that much. And so for them to be that comfortable with it, and then all I have to do is use that model and it gives them a way to organize their thinking. My end goal, of course, is for them to move past using this model. That's always the goal, is for them to move beyond using the model. But there are kids that struggle so much with factoring. If all they ever do is use this, I would be thrilled. They would get so many more correct using this model than just guessing and checking. And they, it's just amazing. It's just amazing. Eventually they'll start to notice patterns. They'll start to see I'm looking for things that multiply to my bottom right corner, that add to what's in the middle. They pick up on that pattern. I don't think I'm even going to tell them that pattern. I'm just going to show them that we're undoing the multiplying that we were doing before, and it's just going to click, and they're just going to figure it out. I'm so excited for this. I think all of the heart eye emojis for this method. I died. I was like so excited. I got distracted and missed probably a good 45 minutes to an hour of the class yesterday because I was messing with this method so much. So thank you so much for joining us on this live. Me. I'm the only one here. Thank you so much for joining me on this live. And I'm so excited. I love sharing math and teacher things with you guys. So thank you so much. And I love you all. And I will talk to you guys later. Mwah!